Okay, today we're going to talk about critical points in Extrema. And this should be probably one of the easier sections. Fairly easy to identify these when we're looking at the picture of a graph. So critical points are any points on the graph at which a tangent line to the curve at that point is going to be either horizontal or vertical. So that is, it has a slope that's either 0 or undefined. So any of those are going to meet the definition of critical points. And once we look at some graphs, you'll have a better understanding of what we're talking about. The absolute maximum is the greatest value that a function assumes over its domain. And the absolute minimum is the least value of a function. So just the opposites here. And then we also have relative maximum and minimum. And the relative maximum is the greatest y value on some interval of the domain, so some piece of the graph. And the relative minimum, the same, just the opposite, the least y value on some interval of the domain. So greatest, least, maximum, minimum. And then points of inflection are critical points on the graph where the graph changes its curvature from concave down to concave up or vice versa. So that's the critical point where it actually changes the direction of the graph. Okay, so when we look at this first graph here, I see I have a peak right here, a valley right here, and this changeover right here is actually the point of inflection. Because this is concave downwards and then this is concave upwards. So kind of right between them here ends up being the point of inflection. And this is a maximum, so you have to really determine, is this the relative or absolute? Well, since my graph here continues to extend upwards indefinitely towards infinity, this would be a relative maximum. And this low point here, this minimum, again, since my graph continues towards negative infinity here, would be a relative minimum. It's not the absolute minimum or maximum because your graph does continue up further towards positive infinity, and towards negative infinity. So these are considered relative max and min. And then if I need to find those values, I can plug this into my calculator. Certainly appears to be maybe at 1, 2, so maybe 1.5, negative 1, 2, positive 1.5. So we can check that. And again, as I move from this point, I do see it appears to peak somewhere here between negative 2 and negative 1. And then it reaches a low here somewhere between 1 and 2. So let's go back to my graph. I'm going to use some of the calculate options, ask it for a maximum. Now, in order for my calculator to produce that, it asks first for the left boundary. So I need to be on the left side of where I believe the maximum to be. I click enter. I move to the right side. Right there, enter. And then I take a guess at it. And it appears as though it's about negative 1.6. And then I'll ask it for a minimum. Again, left bound, right bound, and the guess, and about positive 1.6. So that's how you can use your calculator to try to identify the relative maximums and minimums. Let's take a look at another one. So this one will graph. Pull this up, go to y equals, we'll clear that out. So I want 3x to the fourth, 3x raised to the fourth, minus 4x cubed. Oops. Fourth and over, there we go, minus 4x cubed. And again, this right here is telling me the domain and range of the window that was used to produce this picture. So it's from negative 2 and 2 by a scale of 1. So I just put this into my window dimensions, and -2 to 2 by a scale of 1. We'll graph, and we get this picture again. So again here, I see my graph heads upwards towards positive infinity, so it's coming downwards here, has this little bloop, and this is a critical point. This is again a point of inflection. It's not a minimum or maximum. It could be a minimum if my graph headed back upwards, but see, it just does this little stumble here and then continues downwards. So it's not a minimum, it's just a critical point and a point of inflection. And then down here, I have the lowest point on my graph. So this is going to be your absolute minimum. And my graph heads back upwards. There is no little peak over any given interval here, so there is no relative or absolute maximum. And again, you could use your calculator in order to try to estimate these values. It looks like this one's right at about 2. Or excuse me, at about 1. We can double check that on the calculator. And there we see it right at 1. Okay, one more here. So 1 hour after X milligrams of a particular drug are given to a person, rise in body temperature, T of X in degrees Fahrenheit is given by this equation. T of X equals X minus X squared divided by 9. And we're going to take a look at this graph. So we'll put this in alpha y equals, I can put in the stacked fraction, make it look exactly like that. So X minus, and I have X squared over 9. We'll see again. Sorry, my window is still in the dimensions of the prior problem. So -5 to 12. And -5 by 5. And there we see the same picture. Now, this is an application problem. So again, this person's taking a drug and it does something to the body over time. And what we're looking for is to determine this point right here, 4.5. And again, if I pull that up and look at the maximum, right at 4.5, and my output's 2.25. And what they're asking is, why is this important? Well, again, what's the situation? It says an hour after X number of milligrams, so 4.5 would represent that amount of milligrams, that's your input, of a particular drug given to a person. The rise in body temperature is given by this model. Discuss this critical point. So what we find here is that this dose, 4.5 milligrams, we reach the maximum body temperature. So depending upon what it is that we're trying to accomplish or avoid, that tells me my maximum, and that is the absolute maximum for this problem. That means no matter if I give less, now again we're talking about giving milligrams of a drug, so you would be cut off here at 0 when you're talking about the actual application. And then as I increase and increase that dose, it never rises above this absolute maximum. So that 4.5 milligram dose of whatever this drug is produces the greatest increase in body temperature. So that's what this tells us given this model. Okay, so that's really all there is in the critical points. Bring any questions with you tomorrow, and we'll get a little more practice in class.